Hello everyone, welcome back to Embedded System course. So this is lecture number 3, part number 2. So we were discussing chapter 1, that is 8051 programming in C. So in previous lecture we were discussing about data types in a C programming language that we are going to use while programming for embedded system in C. In this lecture part we are going to uh, discuss about time delay in 8051 using C, that is how to write program to generate time delay in a C for 8051 microcontroller. And also we are going to discuss about IO programming, that is IO port, input output port programming in 8051 using C. So 8051 microcontroller is having 4 ports: port 0, port 1, port 2 and port 3, and its IO programming means how to configure these ports as input or output to input and output data to the peripherals connected to these ports in C programming language. So time delay in 8051 using C. You have already know the use of time delay in programming. You have studied how to write time delay program in assembly programming language and what is its use. So time delay is used in program to just delay the program execution, or to just hold the program execution for some time. That is as per applications requirement, that is use of time delay. So there are two ways of creating time delays in 8051 C programming. Uh, First one is using simple for loop, and second one using 8051 timers. So there are timer 0 and timer 1, and we can employ this timer 0 or timer 1 in a timer mode to generate precise delays. So these are the two ways of creating time delays. So actually there are three factors that affect the accuracy of a time delay we are generating. So first factor is the 8051 design. So we are selecting a particular microcontroller from family of 8051 microcontrollers. So its particular design can affect the accuracy of time delay. Okay, so there are two factors under this 8051 design that affects accuracy of time delay. First one is number of machine cycles. So number of machine cycles, that means how many machine cycles are required to execute a particular instruction, and that also varies from one microcontroller to another microcontroller under 8051 family of microcontrollers. Okay, so that time delay offered by time delay program you have written will be affected by number of machine cycles required by each instruction to complete its execution. Second factor is the number of clock periods per machine cycle. So per machine cycle for a particular microcontroller, there are number of fixed number of clock periods. For example, normally it is 12 clock periods, means one machine cycle, and instructions may require 1, 2, 3 or 4 machine cycles to complete their execution. Okay, so these two factors under 8051 design affects the delay offered by time delay. Okay, second factor is crystal frequency, that is crystal connected between pins x1 and x2. That frequency of crystal affects the uh, accuracy of time delay. Okay, because here that crystal frequency, that is FOSC, that will determine the number of that is clock period of machine cycle. Okay, so if that frequency of crystal varies, obviously the time required to execute instruction also varies, because here number of clock periods are there per machine cycle, and if the clock period varies, means the time period of machine cycle varies, and time required by the instruction to execute that also varies. So in this way, crystal frequency also affects accuracy of time delay. Uh, Third factor that affects the accuracy of time delay is compiler choice. So in case of C compiler, when we compile a program written in C, so the statements in that program which are in a C, that will get converted to assembly language instructions ultimately. Okay, and after that, from these assembly language instructions, hex code will get generated. Okay, now if we use different compilers, C compilers, so they produces different code or hex file, different code in the sense that is bytes number of bytes in that hex file, that varies from compiler to compiler. Okay, so that means if I'm using one compiler, and in that suppose I have written one time delay subroutine, so the time delay offered by that time delay subroutine may not be same if I use different compiler to compile that time delay subroutine. That is the meaning. So these are the three factors that affects the accuracy or time delay being offered by that time delay subroutine or program we have written. So to illustrate this point, that is the first point, that is um, number of clock periods per machine cycle. So I have taken uh, four microcontrollers from family of 8051 microcontrollers. Okay, so in case of 8089C51 microcontroller, 8051 microcontroller being manufactured by Atmel Corporation, clocks per machine cycle are 12. While in case of P89C54X2 microcontroller, 8051 microcontroller manufactured by Philips, clocks per machine cycles are 6. Okay, that means both are under 8051 family of microcontrollers. So this first one requires 12 clocks per machine cycle, and second one requires 6 clock per machine cycle. So meaning is, for particular instruction, this 8089C51 takes suppose X machine cycles to execute. Then uh, second microcontroller being manufactured by Philips, it requires half the time that is required to execute by this first one, that is 8089C51 microcontroller. Okay, because in second case number of clock cycles per machine cycle 6, and in case of this 8089C51, number of clock cycles per machine cycle are 12. Okay, same in case of third one, DS5000 microcontroller manufactured by Dallas Semiconductor. It it requires 4 clocks per machine cycle. Okay, so that means for a particular instruction, time required by this Dallas Semiconductor microcontroller is one third as compared to this 8089C51 Atmel microcontroller. Okay, and in case of last, that is DS89C420304050 microcontroller being manufactured by Dallas Semiconductor, the time required to execute a particular instruction is 1/12 as compared to the time required by this 8089C51. Okay, because here clocks per machine cycle is 1. So for this discussion we are assuming that the clock frequency is same. Okay, in that case this will be whatever we discuss, that will be true. So let us see one time delay that is written by using for loop. So here program is written, write an 8051C program to toggle bits of port 1 continuously forever with some delay in between. Okay, so here the program is written, so slash slash, here slash slash, uh, that is nothing but whatever comes after this double slash, that is comment actually. So in C programming language, actually we use slash star and star slash, and in between whatever text we write, that will be considered as comment by C compiler. Okay, so this double slash we can also use for comment. So whatever text after this double slash, that will be considered as comment. So first two lines are comment. So what is written? Toggle port 1 forever with some delay in between on and off. Okay, so following is the program. So first I'm including reg51.h header file, then void main. So this program contains main function, only one function, and that is main, and program for this main function is enclosed in between this opening brace and closing brace. So this is the program. So here first statement is declaration, variable declaration statement, unsigned int x semi-comma. Here I am declaring x as unsigned int type of variable. Okay. Then next statement is a for statement, and this is infinite for statement because there in between this opening and closing parenthesis, expression 1, expression 2 and expression 3 are not specified. That means this for loop will um, execute infinitely, means whatever program written in between this opening and closing braces, that is this program will execute continuously, infinitely. Now see here what is written inside this for loop. So first statement is p1 is equal to 0x55 semicolon. So that means I am outputting hex number 55 to port 1. Okay, so 55 hex means in binary 0 1 0 1 uh, 0 1 0 1 and 0 1 0 1. Okay, then again one loop is there, for loop, for x is equal to 0, x is less than 40,000 semi comma x plus plus, and here this for loop is terminating. Okay, semi comma means in this for loop there are no statements in loop. Okay, so what will happen when this for loop executes? So this expression will be executed at the starting for only for once, means x will get assigned with value 0, and this is a relational expression. So this relational expression will be evaluated after each pass in the loop, uh, and if this relational expression returns true, this for loop will be continued, otherwise it will get terminated. After execution of each pass, this last expression 3 will be executed. So for starting, x will get assigned value 0, and this expression 2 will be evaluated. Since x is having value 0, this expression will return true, and then whatever statements are there in the loop, that will be executed. But here in this for loop, there are no any statements in the loop. Okay, but still this for loop will be executed because here semi comma is written. That means there are no statements in the loop to be executed. So after this expression 2 returns true, this x plus plus expression 3 will be evaluated, means x will get incremented by 1. Again this expression 2 will be evaluated. If it returns true, again it will obviously return true because x is having value 1 and still it is less than 40,000. Again this expression 3 will be evaluated. Okay, in this way this for loop will be repeated, executing this expression 2 and expression 3 for 40,000 times. Okay, and when this value in x becomes 40,000, okay, it becomes 40,000, this expression 2 returns false, and this for loop will get terminated, and program control execution will get transferred to the statement below this for loop, and that is this statement. Okay, means this for loop, we are just we have put this for loop here to just generate a small delay. Okay, because we are just delaying execution of next instruction, because this for loop will be repeated for 40,000 times, so it will offer some delay of unknown size. Okay, so here we are just holding program execution for some time, that is nothing but time delay. Okay, for how much time that program execution will be held, that is right now it is unknown. Okay, so this for statement is generating some unknown delay. Okay, delaying program execution of next instruction. So next instruction is p1 is equal to 0xAA, means we are outputting AA hex number to p1. AA means 10101010. So previously we outputted 01010101 to port 1. Now what I am doing, I am just toggling this 01010101, and that data I am outputting to port 1, that is 10101010, means I am just toggling data in port 1 by outputting A to port 1. Okay, again I am using same for loop. Okay, so that we discussed, and I am putting same for loop to um, to generate some unknown delay. Okay, and after this delay, again these statements in this loop will be executed, and that will be happen continuously, infinitely. Okay, so that means what I am doing here, first I am outputting 55 to port 1, then I am generating some delay by using for statement, and then I am outputting A to port 1, and again I am generating some delay by using for loop, and that is going repeating continuously or infinitely, means I am continuously toggling data in port 1 with some delay in between, and that is being asked in this program. Okay, so in this way I can generate time delay by using for loop. So one more program is there that generate time delay using for loop, and this program is tested for microcontroller DS89C420 with crystal frequency of 11.0591 megahertz. So program statement is write an 8051C program to toggle all the bits of port 1 continuously with 250 millisecond delay in between. Okay, in previous program the delay we generated, that is unknown, but here in this program what is asked, while toggling port 1 we should have 250 millisecond delay in between. Okay, and while writing this program, what we have assumed, we have assumed that microcontroller is DS89C420 and crystal frequency used is 11.0591 megahertz, because the accuracy of delay is affected by the microcontroller design as well as the crystal frequency that is used, that we have already discussed. Now let us discuss the program written for this program statement. So first pre-processing statement is include reg51.h, then void ms delay, and in a parenthesis unsigned int and semicolon. So this is actually function declaration. So I am declaring a function having name ms delay, and it is not returning any value, so here data type is void, and to this function I'm passing what value. Okay, I'm passing one value whose data type is unsigned int. So this is function declaration. Okay, because its definition is coming after its use. So see here, this program consists of two functions, one is main and other is ms delay, and this ms delay function declaration I am putting here because in this main function I am using this ms delay, and this function definition is coming afterwards. So this is called as actual function program is called as function definition, and it is it is coming after this main function from where I am using this ms delay, or I am calling this ms delay function. So I should have function declaration here. Okay, your compiler should know what is ms delay. So this function declaration is telling your compiler that ms delay is a function which is not returning any value and to which I am passing unsigned int type of value. So this is void main function. In this main function there is a while loop, and while, and in parenthesis there should be condition that should return either true value or false value, but here I have written 1. That means this while loop, uh, that is a condition for continuation of this while loop, is always 1. Means this while loop will get repeated infinitely times continuously. Whatever program in the loop, that will be executed repeatedly. That is the meaning. Means in simple, this is an infinite while loop. Okay, means program in this loop will be executed repeatedly, continuously, infinitely. Okay, so so what is program in this while loop? So p1 is equal to 0x55, means outputting, I am outputting 55 to port 1, means 01 01 01 01. I am outputting to port 1, means I am making port 1 pins 01 01 01 01 first. Then ms delay, means I am calling this ms delay subroutine or function whose definition is following this main function. Okay, here it is. So ms delay, and in parenthesis I am writing 250, means I am passing 250 value to this ms delay function. Okay, now when this ms delay function executes, what will happen? So program control will get transferred to the definition of this ms delay function. Okay, and this 250 value will get assigned to variable I time here I time. Okay, so which is unsigned int type of variable. Okay, so uh, to this I time variable, value 250 will get assigned, and whatever program inside this ms delay function, that will be executed. Okay, now see here, inside unsigned, inside this ms delay function, so first statement is unsigned int I comma j semicolon. So this is declaration statement of two variables I and j of unsigned integer type. Okay, and next is for loop. So this is first for loop. So for I is equal to 0, I is less than I time semi-comma I plus plus. So this first loop will be repeated how many times? I time times. So I time is what? 250. Means this first loop will be repeated how many times? 250 times. Okay, because here condition is I is less than I time, and in I time there is value 250, means this outer for loop will be repeated 250 times. Okay, and in this outer for loop, okay, so there is a nested for loop, means inside this for loop there is another for loop. So this is a for j is equal to 0, j less than 1275, and j plus plus. So this inside for loop will be repeated how many times? That is from 0 to 1274 times. Means this inside or nested for loop will be repeated 1274 1274 times. Okay, so in total these two loops, okay, will be repeated in total how many times? 1274 multiply by 250 times. Okay, and according to the microcontroller for which we have written this ms delay function, that is DS89C420 and crystal frequency of 11.0591 megahertz, if we do calculation, this ms delay function contributes actually delay of 250 millisecond. Okay, so we can do, or we can test this program on machine. Okay, so this ms delay subroutine will offer 250 millisecond of delay. So here after outputting 55 to port 1, what I'm doing, I'm calling this ms delay function and passing value 250 because I require 250 millisecond delay. Okay, means if I pass 250 value to this ms delay, this ms delay function offers 250 millisecond delay. If I suppose pass here 500 value, it will offer 500 millisecond delay. Okay, because this value 1275 we determined accordingly. Okay, considering this microcontroller and crystal frequency of 11.0591 megahertz. So after that delay of 250 millisecond, I am outputting AA to port 1, means I'm just toggling data in port 1. So previously we outputted 01010110. Now I am outputting 10101010. Just I'm toggling data in port 1, and again I am calling this ms delay 250. Means this ms delay function again is called passing value 250, means this ms delay function will generate delay of 250 millisecond again. After that again these statements in the loop will be repeated and this will happen continuously. In other words, what this program is doing, it is continuously toggling port 1 bits or pins with a delay of 250 milliseconds in between. Okay, and that is being asked here. In this way also we can generate precise delay required. Okay, so depending on the microcontroller you have used in your embedded system and crystal frequency uh, of crystal connected to that microcontroller, we can determine this value, constant value. Okay, and we can then generate precise delay. Okay, in this way we can generate time delay using for loop. So next part now is IO port programming. Already you have studied whatever programs we have discussed up till now. So that involves IO port programming. Means IO port programming means what? That is outputting or inputting data from the peripherals that are connected to IO ports of 8051 microcontroller. Okay, so there are 4 ports in generic 8051 microcontroller: port 0, port 1, port 2, and port 3. Okay, so we can program these ports byte wise or bit wise. Means at a time we can output data in byte size to these ports, or reading data from these ports in bytes. So that is called as byte-wise programming. And second option is bit-wise programming, means we can read in a particular bit or pin of these ports, or we can output uh, a bit data to a particular bit or pin of these ports. So that is called as bitwise programming. So we are going to discuss both these types. So first example given here is uh, so sorry so program statement is LEDs are connected to bits P1 and P2, that is bits of port 1 and port 2, that means pins of port 1 and port 2. Write 8051C program that shows the count from 00 to FFH, that is 0000, 0000 to 11111, 11111 in binary on these LEDs. Okay, so for that program is written. So I think you have got the meaning of program. So what is meaning? Port 1 and port 2 pins are connected to LEDs, and what we have to do to both these port 1 and port 2, we have to output data uh, 00 to FFH in hex, or 0000 0000 to 11111 1111. Okay, so for that program is written. So hash include reg51.h header file we are including in our program. Then see here, hash define. So this is not D, this should be E. So hash define and space LED in capital, space P2 and semicomma. So here what I am doing, I am just declaring a symbolic constant, and that symbolic constant is LED. Okay, and what this symbolic constant is representing, it is representing P2. Means instead of using standard name P2, for port 2 I will use LED. Okay, this is just for illustration. In this way also we can do programming. Means I'm representing port 2, instead of P2 I am using LED. Okay, then main function void main void, in between opening and closing braces program is written. So P1 will be equal to 0 0, means I'm clearing port 1, and LED is equal to 0. What is LED here? LED is nothing but port 2, because we have defined, okay, LED as port 2. Okay, so by using these two statements, actually I am configuring port 1 and port 2 as output ports, because I am loading 0 0 value in port 1 and port 2. Okay, that means I am configuring or configuring port 1 port 2 as output port, or clearing port 1 and port 2. Okay, so next statement is for statement, that is infinite for statement, because there are no expression 1, expression 2 and expression 3 between this opening and closing parenthesis. Means whatever statements in the loop, that will be repeated forever, infinitely. Okay, so this is infinite for loop. So what is written here? P1 plus plus semi comma. So this first statement will increment value in port 1. Right now what is value in port 1? 0 0. It will become um, 0 1. Okay, so it will get incremented by 1. LED plus plus means means port 2. Port 2 contents will also get incremented by 1. Okay, after that again this loop will be repeated. Again port 1 uh, content will get incremented by 1. Now it will become 2. Again LED plus plus, this will increment content in port 2, it will become 2. In this way this loop will be executed continuously, varying data in port 1 and port 2 from 0 0 to maximum FFH, and after that FFH again this content in port 1 and port 2 becomes 0 0, and again it will start incrementing up to FF, and this will happen continuously. Okay, means in other words what we are doing, we are actually we are outputting data on port 1 and port 2, which is varying from 0 0 to FFH, and that is been asked in this program. Okay, in this way we can program ports of 8051. Okay, now next part is bit addressable IO port programming. So bit addressable IO port programming means what? Instead of outputting bytes of data on this port, or reading in bytes of data, what we can do, we can read in a particular pin of a port, or we can output data on a particular pin of port. That means we can set or reset a particular pin, or we can read in a data from a particular port pin. Okay, so these all these ports of 8051 are bit addressable, means uh, I can read in or I can output data on a particular port pin. For that we need these port pin addresses. Okay, so every port pin is having different address. So this table lists these addresses for port 0, port 1, port 2 and port 3 pins of 8051 microcontroller. So here port 0, uh, port 0 pins P0.0 to P0.7. So address range is 80 to 87, means this pin number 0 of port 0 is having address 80, pin number 1 of port 0 is having address 81, and so on, and pin number 7 of port 0 is having address 87. In this way port 1 is also having address range of their of its pins ranging from 90 to 97, and port 2 pins having address ranging from A0 to A7, and port 3 having address range from B0 to B7. Okay, out of other SFRs, okay, means port 0, port 1, port 3, port 2 and port 3 are bit addressable. Other than these ports, out of other SFRs only. Accumulator, B register, PSW, that is program status word, IP, IE, SCON and TCON are bit addressable SFRs. Okay, and all other remaining SFRs are not bit addressable. Okay, so here whatever I statement I told, that is the registers marked in red are a bit addressable, that is register B, accumulator, PSW, IP, port 3, IE, port 2, SCON, P1, TCON and P0. Okay, these registers marked in red are bit addressable and their bit addresses are specified here. Okay, so all other remaining SFRs are byte addressable. They cannot be bit addressable. Okay, so to illustrate bit addressable IO port programming, here a program is written. So write an 8051C program to toggle bit D0 of the port P1 50,000 times. So what we are going to do, we have to toggle bit D0, means pin number 0 of port 1, that is P1.0. Okay, so this pin data should be toggled, means first we have to make data on this pin 0 port 1 0, then 1, then 0, then 1, how many times? 50,000 times. For this program is written. So program hash include reg51.h s bit, my bit is equal to p1 caret 0 semicolon. Okay, so here S bit means single bit from bit addressable SFR. So I'm declaring my bit as S bit type of uh, variable, and to which I am assigning port 1 pin number 0 address. Okay, so port 1 pin number 0 address is 90. Okay, so what will happen after execution of this declaration statement? So my bit will get assigned with address of pin number 0 of port 1, which is 90. Okay, and my bit I can refer to this pin, that is pin 0 of port 1, by using name my bit, so that my programming will be easy. So then void main void function. So program is written inside this main function. So first statement is declaration statement, unsigned int z. So I am declaring z as unsigned int type of variable, and then for loop is there, and inside this for loop first expression is z is equal to 0, means z, this variable will be initialized with value 0, and z is less than or equal to 50,000. This is expression 2. So this is a relational expression that will determine whether to continue or not this loop. Okay, that is condition for continuation of this loop. And expression 3, as usual, it is uh, increment expression, that will increment z variable. Now when this for loop executes, first time z will get initialized with value 0, then this expression 2 will be evaluated. So z is less than or equal to 50,000. Right now z is having value 0, means this expression will return true, and when this expression returns true, then the loop statements will be executed. Okay, so what is written in loop? So my bit will be equal to 0, means this my bit will get assigned value 0. So what is my bit? My bit is nothing but pin number 0 of port 1, means first this port 1 pin number 0, okay, will get reset, it will get assigned value 0, means it will get reset, means it will output 0 on pin number 0 of port 1, and then immediately I am making it 1, because I am assigning my bit equal to 1, means I am just toggling this pin number 0 of port 1. Okay, inside this loop. After that z will get incremented by 1, again this condition will be checked, again it returns true, again this toggling of this pin will be done due to statements in loop. Okay, that is pin number 0 of port 1. So this will happen continuously until this condition becomes false. When this condition becomes false, when this value in z becomes 51,000. Okay, means this loop will be repeated for approximately 51,000 times, because here equal to is there. Okay, if equal to is not there, this loop will be repeated 50,000 times. Okay, so 50,000 times this pin number 0 of port 1 will get toggled, and that is what is been asked in the program. We are toggling pin number 0 of port 1 continuously how many times? 50,000 times. So you have to remove this equal to sign here in this relational expression, so that this program will cause toggling of port pin 0 of port 1 50,000 times. Okay, next program, uh, write an 8051C program to monitor bit uh, P1.5, that is pin number 5 of port 1, and if it is high, send 55H to port 0, otherwise send AAH to port 2. Okay, so we have to monitor pin number 5 of port 1, and if it is 1, then we have to send 55 to port 0, otherwise we have to send A to port 2. Okay, so in this program we should configure this pin number 5 of port 1 as input, because we are monitoring it, and we have to configure port 0 and port 2 as output, because we are going to send data 55 to port 0 or A to port 2, depending on whether P1.5, that is pin number 5 of port 1, is high or not. Okay, so this is the program written. Hash include reg51.h s bit my bit equal to p1 caret 5 semi-comma. So here, by using this statement, I am declaring my bit as s bit type of variable, and I am assigning address of pin number 5 of port 1 to this my bit. Means I am representing pin number 5 of port 1 by my bit variable. Okay, so this is main function. Inside this main function, first my bit is equal to 1, means I am configuring my bit. My bit is what? That is pin number 5 of port 1. I am configuring this pin as input. Okay, while 1 means this is infinite while loop, so whatever statements in the loop, that will be executed infinitely or continuously. Okay, so here if my bit is equal to 1, so this is a relational equal to operator. Okay, so this is a relational expression. So my bit is equal to 1 means this relational expression will be will return true if my bit is 1. Okay, otherwise it will return false. Okay, means if this my bit is 1, this statement will be executed, and if my bit is not 1, then else this statement will be executed. Okay, means if my bit is, that is pin number 5 of port 1 is high, then we have to send 55 to port 0. Okay, so if my bit is equal to 1, if this is true, then 55 will get sent to port 0, otherwise A will get sent to port 2, and that is being asked in this program. That is, if it is high, that is pin number 5 of port 1 is high, send 55 to port 0, otherwise send A to port 2. So this if statement, if else statement is doing this job. If statement is checking this condition, and if this condition is true, means by my bit is 1, means pin number 5 of port 1 is 1, then we are outputting 55 to port 0, otherwise we are outputting A to port 2. One more program is there. A door sensor is connected to port 1 pin number 1, and a buzzer is connected to port 1 pin number 7. Write an 8051C program to monitor the door sensor, and when it opens, sound the buzzer. You can sound the buzzer by sending a square wave of few hundred hertz. Okay, so port 1 pin number 1 is acting as a input, because sensor is connected to this port number pin number 1 of port 1, and buzzer is connected to pin number 7 of same port, that is port 1. So this port pin 7 of port 1, it should be output, because buzzer is connected, buzzer is being controlled by this pin, so it should be output. Okay, we have to write program to monitor the door sensor connected to pin number 1 of port 1, and when it opens, we have to sound the buzzer. Means open means door is open, so then we have to turn on buzzer. How you can turn on buzzer? Just we have to send a square wave to this buzzer of a few hertz. Means we have to generate a square wave on this pin P1.7 once we find door is open. Okay, so for that program is written. See here, include reg51.h, avoid ms delay, so ms delay subroutine, or function declaration is there. S bit D sensor is equal to P1 as caret 1, means I am declaring D sensor as S bit type of variable, and I am assigning address of pin number 1 of port 1. Okay, means I am representing pin number 1 of port 1 by using this variable D sensor. And similarly, I am declaring buzzer as S bit type of variable, to which I am assigning address of pin number 7 of port 1, means I am representing pin number 7 of port 1 by using buzzer variable, and I am representing pin number 1 of port 1 by using D-sensor variable. Okay, from program now I can use these D-sensor and buzzer instead of P1 this P1 caret 1 and P1 caret 7. So this is main program. So D-sensor is equal to 1, means I am configuring this P1 port 1 pin number 1 I am configuring as input because sensor is connected here, and this is a infinite while loop. So whatever program in this loop, that will be executed infinitely, continuously. Again, inside this infinite while loop there is a while loop. So while D sensor is equal to 1, so this is a relational expression. It is checking or comparing D sensor with 1. Okay, D sensor means what? That is pin number 1 of port 1. If it is 1, then the statements in this nested while loop will be executed. Means when it is open, means D sensor will output this uh, pin number 1 of port 1 will output 1. That means door is open. So if it is open, then we have to we have to turn on the buzzer by sending a square wave of frequency of few hundred hertz. So that program is written inside here, this nested while loop. So buzzer is equal to 0. First we are making this P1 port 1 pin number 7 0, and then I am calling this 200 millisecond delay, and then I am making this pin 1, and I am calling same delay, means I am just generating square wave of 400 millisecond delay on this pin number 7 of port 1, which is connected to buzzer, and buzzer will generate sound. Okay, so in this way, if door sensor is 1, means here we are getting 1 on this pin number 1, means door is open, and if it is outputting 0, means door is closed, and this program in this loop will not be executed, means this square wave will not be supplied to buzzer, and buzzer will be off. In this way, whatever been asked in this statement, the program is working. So one more program is there, write an 8051C program to get the status of bit P1.0, save it and send it to port 2 pin number 7 continuously. That is of same. Okay, so few programs for your exercise are given here. 3 programs are there. This is assignment for you. You can write program for these 3 statements given. Okay, so this is about time delay and IO port programming. So we will stop here.